Hello, everyone. So in this week, we are going to study dynamic programming. Uh, Now, before we get into that, I want to talk about in general, algorithmic strategies which uh, revolve around this divide and conquer strategy. So in your course of algorithms, I'm sure you must have used it. So imagine that we have a problem and we can break that problem into subproblems. Um, but each of those subproblems are not dependent on each other, okay? And so we break a problem into subproblems which are independent, solve each subproblem, and then combine the results of each subproblem, to solve our original problem. So this is the generic strategy of divide and conquer methodologies. We follow a rather similar approach in dynamic programming as well, but here the difference is that instead, like the subproblems that we devise are actually overlapping in some sense. And by overlapping, I mean that you can encounter, let's say, if you have a subproblem, you can encounter that subproblem somewhere else while you're, let's say, recursively dividing your subproblems into mini subproblems. Okay, so you can have a situation where those subproblems are overlapping, and by overlapping, I mean that you don't need to, let's say, solve each subproblem multiple times, given that they are basically the same. And so in dynamic programming, we sort of do this divide and conquer strategy, but do it in a clever way. We divide our problems into overlapping subproblems and avoid solving each of those overlapping problems multiple times. So this is the only difference between dynamic programming and a traditional divide and conquer strategy. Um, Now, so what we are going to do is basically, the best way to do the dynamic programming is to solve problems. And for each problem that we are going to solve using dynamic approach, we will first start by using naive implementation, naive recursive way of doing things. Now, we call this a top-down implementation in the sense that we have a large problem. We break it down into smaller problems and then recursively solve each of those smaller subproblems, and then combine our way up. So this is the top-down approach in the sense that we start from the top and basically follow a downward strategy by solving, by, let's say, dividing each problem into subproblems and then solving that subproblem. Now, if we for each of the problem that we are going to solve, if we simply use recursion, we will see that most of the times we'll end up having an exponential complexity. So let's say 2 to the raised power n, 3 to the raised power n, and even sometimes higher base of these exponential, which is obviously bad. And then so when we first write recursive solution, then we will try to be smart, and instead of doing this recursion on the same problems multiple times, we are going to use a memo or a register where we are going to simply memorize results of any subproblem that we have encountered before, so that not to solve that subproblem multiple times. And so this will help us avoiding this exponential complexity by bringing it down into polynomial domain. So instead of anything raised to the power n, we will try to solve our problems let's say in quadratic or cubic terms. So n is basically, imagine that you have an array containing 100 elements. Let's say n is 100. So obviously 2 to the raised power 100 is way bad than 100 square, for example. So like when we talk about dynamic programming, we actually mean this memoing strategy, where we use recursion plus memo to be in some sense clever about recursive results. But then instead of using this approach, we can also have bottom-up implementation, where instead of using recursion, we will try to solve the same problem using iterative method, using for or while loops. And that will, well, so that depends, but at least in terms of time complexity, we will see that most of these approaches, these bottom-up approaches, where we, instead of starting from top problem, we start from the base sub-problem and then solve it iteratively until and unless until we reach our main problem. So that will be a bottom-up strategy, and you will use iterative method for that. Uh, and that will also end up having the same complexity as this memo approach. Okay, so for each problem we are going to devise basically 3 solutions. um, the first 2 will be top-down approaches, the first one being simple recursion, the second one being let's say clever way of recursion, and then the third way will be the bottom-up iterative solution that can also replace the top-down implementation. So for next couple of problems, we are going to see these 3 different strategies for each of our dynamic problems. See you then.